Welcome to the deep dive. Today we're getting into something really foundational. It's behind so many products you use every day, but you probably don't think about it much. Good manufacturing practices, or GMP.
That's right.
Our mission today: uncover the rules, the principles that make sure products are safe, high quality, reliable.
And it's more than just factory rules, isn't it? It's really about a commitment to you, the customer, to satisfaction, to safety.
Okay.
And our source material today, this GMP training guide, it really peels back the layers on that commitment. It shows how deep it goes.
Okay, let's unpack this then. GMP. What is it really at its core?
Well, the source defines it as the part of quality assurance aimed at ensuring products are consistently manufactured.
Consistently.
Yeah, consistently, to a quality that's right for their intended use. So it's about making sure what's on the label is, well, what's in the box every single time.
Great. Every time. So reliability.
Exactly. The main goal, the purpose of GMPs, is ensuring products meet all the requirements. Safety, identity, quality, purity. All of them.
And quality here isn't just vague goodness, is it?
No, it's specific. It means conformance to requirements and fitness for use. Does the product do what it's supposed to? Reliably. That's quality.
Okay, that makes sense. So you mentioned quality assurance. How does GMP fit in? QA sounds broader.
It is broader, yeah. Quality assurance covers a lot, including things like, say, initial product development, stuff the folks on the floor might not touch daily.
Ah,
But GMP, that's the hands-on part. The source calls it the day-to-day part of quality assurance. It's where the action is, on the ground.
got it. The practical application.
Precisely. And because it's so practical, it involves, well, everyone. People actually making the product, packing it, storing it, testing it.
But also the support staff.
Absolutely. Cleaning crews, maintenance teams, people keeping the records, everyone plays a part. It's a collective thing.
So why should you, our listener, care about all this?
Well, think about medicine you might take.
Yeah.
For it to be fit for use, it absolutely has to be the right product, right strength, no contamination, not gone bad, right container, correct label, properly sealed.
Okay, yeah, that's a lot.
It is. And GMP is the system that makes sure all those things are right. It's why you can generally trust what's in your medicine cabinet, or your food pantry for that matter.
Right. It's that underlying trust.
Mm-hmm. And GMP, it can stand for practices, procedures, or principles. But the key takeaway, these rules, these principles, they apply to everyone involved, no exceptions.
And they have to, right? Because the product just must be right.
Exactly right. Feel, smell, taste, look, act the way it's supposed to. Correct identity, strength, quality, purity, no wiggle room.
Because if it's wrong.
The consequences are huge, which is why there are three main drivers for GMP. Legal is one.
Like regulators. MedSafe, FDA, TGA.
Yep, exactly. Then there's corporate company policy, protecting the brand,
Makes sense.
And finally, moral. Especially with health products, there's a moral duty to make sure it works and is safe. You promise something to the customer.
And the costs of getting it wrong.
Yeah.
Wow. The source lists them out. Wasted materials, labor, delays, complaints.
Oh, yeah. Recalls, damaged reputation, legal action. It gets very expensive very fast. Way beyond just the cost of the bad batch.
So the core goals of GMP are crystal clear then.
Absolutely. Non-negotiable. No mix-ups. No contamination.
Yeah.
And no lack of product performance. Those are the big three.
Okay, let's break those down. No mix-ups. Sounds simple, but I guess it's easy to mess up.
Surprisingly easy without strict systems. Think about using the wrong ingredient, or grabbing the wrong label, or maybe the wrong strength of something.
Like vitamin C 500 milligrams instead of 1,000
Yeah,
milligrams.
exactly that kind of thing. Small errors, huge potential impact. GMPs are built to prevent exactly that.
Okay. Then no contamination. What forms does that take?
Several. Microbial is a big one. Bacteria, yeast, molds. Then there's cross-contamination.
Like traces of one product getting into another.
Precisely. And foreign matter, anything that just shouldn't be there. A
Yeah.
hair, dust, maybe a tiny metal fragment. All bad news.
And the third one, no lack of performance. What does that mean?
It means the product has to work as intended. So maybe a capsule is only partly filled, that's low dosage.
Right.
Or perhaps a tablet doesn't dissolve properly in the body, so you don't get the medicine's effect. It might look okay, but if it doesn't perform, it's a quality failure.
Got it. So mix-ups, contamination, lack of performance.
Mm-hmm.
We avoid these for legal, corporate, moral reasons.
Mm-hmm.
And the way we do that is by having everyone in the plant follow these rules. these GMPs.
That's the foundation, yes. Collective vigilance.
Okay, so moving on from the what and why, let's look at the pillars holding this up, starting with the people involved and the place itself, the buildings.
Yes, the people aspect is absolutely central. It starts with training, formal GMP training, specific job training using SOPs, standard operating procedures, and on-the-job learning.
And it all needs to be written down.
Documented, yes. Crucial. SOPs ensure everyone does the job the same way, preventing missteps. And it's not just how to do it, but understanding why. That why is key to avoiding shortcuts.
Right. Understanding the reason behind the rule.
Then there's health and hygiene. Some rules protect the staff, sure, but many are about protecting the product.
Like reporting illness.
Definitely. Reporting illness, any open sores, that's critical to prevent microbial contamination. Hand washing, obviously, is huge. And strict rules about no eating or smoking, except in designated areas way outside the plant. Food attracts pests, you see.
Ah, good point. Okay, what about clothing?
Special clothing is another big one. It's not just a uniform, it's a barrier. Overalls, hairnets or hats, making sure all hair is covered, masks, gloves, shoe covers. It varies, but the principle is protection.
Protection for the product from us, basically.
And sometimes protection for us from the product. But a key rule, raw materials and the product itself, never touched by bare hands, ever. And if you leave the building, that protective clothing comes off.
Makes sense. Then there's attitude. How does attitude fit in?
It's surprisingly direct. A genuine concern for quality, a positive attitude, makes people want to follow the procedures correctly. It encourages care, attention to detail, and avoids that temptation to cut corners or be careless. It's a quality mindset.
So it's not just QA's job.
Well, quality assurance has specific roles. Yes, approving materials, reviewing records, but the source is clear. We are all part of the quality process. Everyone should act like a quality inspector in their own role.
Everyone's responsible.
Exactly.
Okay, here's where it gets really interesting for me. Let's talk about the buildings, the physical space.
Right. Because even with the best people, the building design itself is critical for GMP. Plants are designed specifically to reduce the chances of mix-ups, contamination, and product failure.
How so? What are the key features?
Well, first, space. You need enough room for physical separation. Keep quarantine materials away from released ones. Store labels securely and separately. Have space between packing lines, space around equipment to prevent cross-contamination, and allow for cleaning.
Okay, separation. What else?
Light. Seems basic, but you need good lighting to check materials, read scales, check labels, read tiny batch numbers and expiry dates, monitor equipment, spot problems early. Bad lighting hides mistakes.
Yeah, I can see that.
Then plan flow. Materials and people should ideally move in one direction through the facility. Unilateral flow. It helps prevent mix-ups and contamination from things backtracking or crossing paths unnecessarily. And strict access control only authorized people in production areas.
Like a one-way street for material.
Sort of, yeah. And environmental controls. Doors and windows kept closed, surfaces easy to clean and kept clean. No food except in designated break areas. Controlling the air, temperature, humidity where needed.
Creating a clean bubble.
Pretty much. And finally, maintenance. Equipment needs to be easy to clean, made of non-reactive materials. No rust, no flaking paint, those are contaminants. And crucially, preventative maintenance. Fixing things before they break and potentially ruin a batch.
Okay, so it's the people there, training, hygiene, attitude, combined with a really well-designed, well-maintained building. That's the formula.
That's a huge part of assuring quality, yes. It
Yeah.
all has to work together.
All right, so we have the people in the place. What about the systems, the procedures that make it all happen consistently?
Right. Systems. Every company has tons of systems, usually written down in those SOPs we mentioned. But for GMP, there are 3 really fundamental systems everyone needs to grasp: identification, double-checking, and documentation.
Okay, identification, what does that involve?
It means everything needs a label showing its status. Every room, area, piece of equipment, every container of material or product. Is it quarantined? Released? Rejected? Clean? Needs cleaning? You need to know instantly just by looking. Even stuff waiting to be used. Clarity is key.
Total clarity. Okay, what about double checking?
This is a huge safety net. Because let's face it, people make mistakes. We all do. So critical steps require a second person, another operator, a supervisor, QA, to independently verify that the step was done correctly. Both people sign off.
2 sets of eyes.
Exactly. It catches errors before they cause a problem with the product, vital for preventing mix-ups and contamination.
And the third one, documentation.
Documentation. If it isn't written down, it didn't happen. That's the mantra. Documentation traces the entire history of a batch, from raw materials coming in the door to the finished product going out. These are legal records. They have to be accurate, complete, legible, and readily available.
Everything recorded.
Everything. This leads to what the source calls the 10 rules for making sure these systems work properly.
Okay, give us a highlight or two.
Well, rule #2 is crucial. Follow instructions, exactly. No cutting corners. Procedures exist for very specific reasons, often learned the hard way. If you're unsure, you ask. Any deviation needs QA sign-off.
Right, stick to the script.
Pretty much. And rule #9. Report mistakes. Immediately. This is tough culturally sometimes, but vital. Mistakes are chances to fix the system. Hiding them puts customers at risk and prevents improvement. Transparency is safety.
That's a big one. What else stands out?
Rule #8. Keep things clean and tidy, including yourself. People are often the biggest source of contamination. So proper gowning, clean workspaces, it directly impacts product purity. It's an active defense.
So putting all these systems together, identification, double-checking, documentation, following the rules, what's the outcome?
The outcome is consistency and safety. It means every batch should meet its specs for identity, strength, quality, and purity. It means achieving those big goals. No mix-ups and no contamination and no lack of performance.
So it's doing the job exactly right.
In the same way, time after time, batch after batch, predictability, reliability.
Okay, and these written systems, the SOPs, they cover more than just these three fundamentals.
Oh, yes. Things like using only approved manufacturers, defining product specifications, how audits are done, identification uses specific labels. We talked about quarantine, released, rejected, clean status tags. Double checks, as we said, need those 2 signatures.
And the documentation is really a legal thing.
Yes, it's a legal record, proof. But also practical, it helps trace problems if they arise. You've got the batch manufacturing records, packing records, lab test sheets, those track the product, but also logs for equipment calibration, cleaning, maintenance, tracking the facility's status.
They're a complete history.
A complete traceable history, and there are strict rules for these records too, like recording things as they happen, not trying to remember later.
No backdating.
Definitely not. And corrections. You don't scribble out or use whiteout. You cross out neatly with one line, sign, date, and explain the change. Keeps the history clear and auditable.
Wow, okay. That level of detail is intense.
It has to be.
So let's talk about something specific where this really matters. Labeling.
Critical area. The rules are very strict. All materials, equipment, rooms need labels, product name, strength, batch number. Clear, unambiguous labels, often color-coded. Green for go, passed. Red for stop, rejected.
Visual cues.
Very important. And if you fill containers but can't label them immediately, you use special status labels in the meantime to avoid any confusion.
And you mentioned 2 types of labels earlier.
Right. There are identity or status labels. Those are for internal use. Quarantine, released, cleaned. They tell staff the status of something within the factory.
The internal GPS.
Good way to put it. Then there are the product labels. These go on the final pack, the ones you see as a customer. They have the product name, batch number, expiry date, instructions, etc.
And controlling these labels is paramount.
Absolutely paramount. The source puts it starkly. Giving a patient the wrong medicine or wrong strength because of a label error could be fatal. That really says it all.
Yeah, that hits home. So how do you control them?
Careful handling, secure storage. Never leave labels just lying around. Report any damaged, peeling, or misplaced labels immediately. Don't put status labels on lids. Lids get swapped.
Good point.
Old labels must be removed or completely obliterated. Never stick a new label over an old one except that specific case of released over quarantine if the info matches. It's all about preventing a mix-up reaching the patient.
And recalls. You said labeling is a major cause.
The biggest cause, according to the source. Mislabeling or mix-ups of printed packaging. That's why label reconciliation is done.
Reconciliation, counting the labels.
Exactly. After a batch is labeled, you account for every single label issued, how many used, how many damaged, how many unused and returned. If the numbers don't add up, it's an immediate red flag. Something might be wrong. You can count them or weigh them. Counting is more accurate.
A final check to catch errors. Okay, let's shift slightly to another precision task, weighing.
Equally critical. Staff doing weighing needs specific training GMPs, weighing techniques, safety, and that attitude of concern we mentioned, understanding the importance. And special clothing again.
Yes, for product protection and sometimes employee protection. Containers must be clean, properly labeled, right size and type for the material.
And the weighing process itself.
Very structured. Use FIFO, first in, first out for raw materials. Only use materials confirmed as released. Clean containers before opening them. Weigh only one material at a time in the weighing area to prevent mix-ups.
One at a time makes sense.
Before weighing, double-check the material against the batch record name, code, batch number, expiry date, status. Tare the container accurately, weigh the exact amount needed. Label the weighed material immediately. Complete the paperwork.
And the double check.
Crucial. Someone else must independently verify the material identity, status, and the weight, and sign off. Then store the weighed materials properly to prevent deterioration. Light, heat, moisture control.
Okay, meticulous. Now let's dive deeper into personal hygiene and cleaning. We touched on hygiene, but let's explore more. Absolutely. Detailed hygiene programs are essential, tailored to the plant, covering health, specific hygiene practices, clothing requirements. Everyone entering production or control areas must understand and follow these strictly.
And management promotes this.
They have to. It's discussed in training. There are often health checks before hiring, and staff must report illnesses or conditions that could affect products. No one with an infectious disease or open skin lesions should be working directly with products.
And the rules about eating, drinking, smoking.
Strictly prohibited in production and storage areas. No storing personal food or medicine there either. Any unhygienic practice is banned. No direct hand contact with exposed products or product contact surfaces. Use the hand washing facilities, always.
So, specifically, how do we stop spreading contaminants?
It's a list of actions. Wash hands frequently and properly, change overalls regularly, keep hair completely covered, wear designated shoes or covers, use gloves, beard masks if needed, follow SOPs precisely, cover cuts, filtered air where required, tell your supervisor if you're sick, don't cough or sneeze over products.
It's a lot of small things adding up.
It is. Hygiene is about preserving health, both the products and the persons. Overalls protect both ways. Hand washing is maybe the single most important habit.
And this is all because of microbes.
Primarily, yes. Bacteria, molds, yeasts, they're microscopic everywhere and multiply incredibly fast in the right conditions. Warmth, moisture, food.
Like E. coli.
E. coli, S. aureus, those indicate human contamination. Their presence is a problem. Large numbers can make people sick or spoil the product.
And since the customers might be vulnerable.
Exactly. Sick people, elderly, infants, they have lower resistance, so we have to take every precaution to ensure products are fit for use. No compromises.
Which leads us directly to cleaning.
The other side of the hygiene coin, you need validated cleaning procedures. Key terms here are clean area, meaning controlled environment, and cross-contamination, preventing residue from one product getting into the next, and validation, proving your cleaning method actually works, every time.
And the GMP code emphasizes this.
Heavily. Premises kept clean, disinfected per written procedures. Equipment designed for easy cleaning, kept clean and dry. Work areas cleaned before starting. Sometimes dedicated facilities for highly sensitive materials like penicillins to prevent any chance of cross-contamination. Cleaning procedures need periodic revalidation too.
So what's the goal of cleaning? Just making things look nice?
Oh, much more than that. It's about removing soil product residue, chemicals, bacteria by dissolving or suspending it so it can be washed away. Residues can feed microbes, cause allergies, or even chemically affect the next product made in that equipment.
How do you do that effectively?
It's usually a combination of physical action, like scrubbing, chemical action from detergents, and heat.
And there's a cycle.
Typically, yes. 4 steps. 1, pre-rinse to get rid of the worst of it. 2, the main wash with detergent. 3, a final rinse to remove detergent and residues, might be water or maybe alcohol, depending on the product. 4, sanitization, often with alcohol or another approved sanitizer, to kill remaining microbes.
What makes cleaning effective? What are the key ingredients?
Several things. Detergents are key. They make the soil easier to remove. Different types for different jobs: acid, alkaline, chelating agents for hard water, surfactants for fats.
Okay.
Temperature helps a lot. Most detergents work better hot, especially for greasy stuff. Time, longer contact helps detergents work. And physical energy scrubbing, water jets like in a dishwasher, or clean-in-place systems. These factors trade off more heat, might mean less scrubbing needed, for example.
And sanitizers, you mentioned those.
Right. They kill bacteria without leaving harmful residues. It's not full sterilization, but reduces the microbial load significantly. Things like quaternary ammonium compounds, chlorine-based ones, phenols, or commonly 70% ethanol. They work in different ways to kill bacteria.
So the bottom line is,
Clean products only come from a clean facility using clean equipment, period. It's up to everyone to ensure that. We need to get rid of dust, grease, hair, insects, any unwanted stuff.
Because microbes are everywhere and multiply fast.
Exactly. So you need a regular, documented cleaning and monitoring program following validated SOPs.
When what gets cleaned?
Everything. Outside areas, entrances, inside walls, floors, ceilings, all equipment manufacturing, packing, lab gear, scales, everything that could possibly affect the product.
And after cleaning,
Cover cleaned equipment immediately, scoops, funnels, etc., to keep it clean until use. Stick to the cleaning schedule, document it all in logs. There are rare, controlled exceptions for back-to-back batches, but cleaning is the default.
how do you know the cleaning worked?
Validation. The cleaning methods must be proven effective through testing, approved by QA, and then followed exactly, with everything logged.
And the logs show.
What was cleaned, when, how, by whom, and who checked it. Vital records if there's ever a problem down the line. So, clean to prevent contamination, follow validated SOPs, document everything.
Okay, so let's move to the final section. Measuring success. Compliance. How do we know all this is actually working?
Good question. GMP compliance isn't a one-off thing. It's continuous improvement. You need ways to measure how well the systems are working so you can take corrective action if needed.
What does the GMP code say about measuring?
It requires things like self-inspections or quality audits, procedures for handling complaints and defects, systems for recalling products if necessary. And those records we talked about, proof that sampling, testing, inspecting happened, and deviations were investigated. Also, in-process controls.
In-process controls, what are those exactly?
They're checks done during production, monitoring the process, the environment, the equipment to make sure everything stays within specification. It allows for real-time adjustments to keep the batch on track, catching problems early.
And audits, you mentioned internal ones.
Right. Internal audits are systematic checks to see if what you're actually doing matches what your procedures say you should be doing, your SOPs. And if those procedures are effective, it's holding up a mirror to your own systems.
Why are audits important for management?
They give management an objective view of how well things are working, avoids biased reports, helps different departments communicate about quality. It's about oversight and accountability.
And there are different kinds of audits.
Yes. Internal is auditing yourself. External is when you audit your suppliers, making sure their quality is up to scratch. And extrinsic audits are by outside bodies, the regulators, like the FDA or TGA, coming to inspect you.
The big inspections. Okay. What about process control?
That's about understanding and controlling the natural variation in any process. You need planned, disciplined data collection and analysis. This helps find the root causes of problems, maybe a bad procedure, poor training, environmental issues, getting to the why.
And once you find the why,
You make corrections. If data shows too much variation, you investigate, maybe change the process. Data gives you facts to manage by. Things like control charts help you see trends visually.
makes sense. Are there other ways to measure compliance?
Customer complaints are a huge source of feedback. There needs to be a formal system. Log the complaint, investigate thoroughly, check batch records, retain samples, maybe retest. Find the cause, respond to the customer, maybe replace the product.
And keep track of complaints.
Absolutely. Track trends. Are you getting lots of complaints about one specific thing? That points to a systemic issue needing fixing.
Okay. Lastly, specifications and yield. How do they fit in?
Products have to meet predefined specifications before they can be released. These might be from pharmacopoeias like BP or USP or internal company standards. Raw materials also have specs. Specs can cover chemical purity, physical properties like tablet hardness, temperature ranges during manufacturing. They're the quality targets.
And yield.
Yield is basically how much product you actually got compared to how much you theoretically should have gotten. For example, if you aim to fill jars to 505G and your final yield is only 98% of the expected number of jars, maybe you were overfilling them, or some got lost or rejected.
Or if yield is over 100%.
That could mean you underfilled, or maybe something extra got in. Yield calculations are a powerful check. If the yield is way off target, it immediately signals a potential problem, maybe a mix-up or wrong amounts added. It's another layer of control.
Wow. Okay, that was quite the journey through GMP.
It's a big topic.
It really is.
Yeah.
But it's clear it's way more than just rules. It's this whole ecosystem, isn't it?
Yeah.
People, buildings, systems, documents, checks, all working together.
All aimed at that consistent safety and quality.
It's kind of amazing to think this intricate system is humming along behind the scenes. For so many things we just take for granted, it builds that quiet trust.
It does. So here's a thought to leave you with. Given everything we've talked about regarding GMP, think about something you use every single day. Could be food, could be soap, maybe even, I don't know, a software app you rely on.
Okay.
How might those core principles, quality assurance, documentation, constant checks, continuous improvement, be working invisibly in the background for that product or service, ensuring your satisfaction, ensuring your safety, even if they don't call it GMP? It makes you wonder where else that commitment to quality is hiding in plain sight, doesn't it?